Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, topic here that we will discuss over there it is the introduction to noble gases. Now, what does mean by the noble gases and what is the main place of these noble gases in the periodic table? So, let's have a look on it. Noble gases. These are basically placed in the group 8A in the periodic table as they are having their group number 8A. So, that's why they have 8 electrons in their valence shell. The valence shell means the outermost shell in which the electrons are residing which can take participate in the chemical reaction. As they have 8 electrons in their valence shell, so they do not require to lose or to gain electrons. So that's why they do not react. And when they do not react, it's mean they are chemically inert substances. And for this inertness, they are called as noble gases. Now, how many noble gases are present in the periodic table? The first one is the helium, its symbol is He. Then we have neon as Ne, we have argon Ar, then krypton is Kr, xenon is Xe, and radon is Rn. So these are the basically six noble gases that are present in the group 8A in the periodic table. All they have 8 electrons in their valence shell. Their valence shell is complete. So they do not need to gain or lose the electrons. So that's why they do not react chemically and they are called as inert gases, and for their inertness they are being called as the noble gases. If we just draw here the helium, its atomic number is 2. So its first shell that contain two electrons, its duplet is complete. So that's why it is a stable gas. It is called as the noble gas. On the other hand, if we talk about the neon, its atomic number is 10. Its first shell and then second shell. Its first shell contain two electrons and its last one shell contain 8 electrons. So its octet is complete and it do not require to lose or to gain the electrons. After its simple introduction, here we have some properties of the noble gases which are called as their physical properties. Now, what are their main physical properties? Let's have a look on it. So the first one gas is the helium gas. We will discuss the atomic number of all these gases. Atomic number of the helium, here we have it is 2, and for neon it is 10, argon 18, krypton 36, xenon 54, and radon 86. So as their atomic number is this, so that they contain the number of electrons and protons equal to this. After this we have their electronic configuration. The first one is helium. It's contain two electrons, so its electronic configuration is 1s2. On the other hand, we have neon. Its atomic number is 10, so containing 10 electrons, and its valence shell contain 8 electrons like 2s2 and 2p6. Likewise, argon, its valence shell will be 3s2, 3p6. Then we have krypton, the valence shell is 3d10, 4s2, and 4p6. Then we talk about the xenon, its valence shell is 5s2, 5p6 that contain 8 electrons in its valence shell. Then we have radon, its valence shell is 6s2, 6p6 again containing 8 electrons in the valence shell, so that's why their octet is complete. Then we talk about their ionization energy. We want to remove their electron from the valence shell. For example, here we have an atom and we just want to remove the electron that is present in its valence shell. To remove this electron, we have to provide some energy to this atom. So the amount of energy that is being absorbed in this process, it will be called as the ionization energy. Now the ionization energy of the helium, here we have 2372 kilojoule per mole, which is the unit for the energy. Then for neon, we have 2080, argon 1520, 1351, xenon 1170, and at the end we have radon. So when we move from top to bottom in the group, their ionization energy decreases. Then we talk about their atomic radius. Atomic radius just depends upon the atomic number. And if the atomic number is higher, then there is an increase in the atomic radius in picometer. Helium, its atomic radius is 31 picometer, neon is 71, argon for 98, krypton 112, xenon 131, and for radon is 140. It means as we move from top to bottom in the group, with the increase in the atomic number, there is an increase in the atomic size. On the other hand, when we talk about the melting point, which is in degrees Celsius, the melting point of helium is minus 246, neon minus 249, and argon minus 189, and so on. When we just move from helium to radon, here its melting point is minus 71. So there is an increase in the melting point when we move from top to bottom. This is also going to be increased. Then we talk about the boiling point. It is also in degrees Celsius. Helium, its boiling point is minus 269, and neon is minus 249, argon minus 186, and when we move at the radon, it is minus 62. There is also an increase in the boiling point when we move from top to bottom in the periodic table for the noble gases. Then the second last is water solubility, that is milliliter ml per liter, and the temperature is here 20 degrees Celsius. So the solubility of helium in water is 13.8, neon is 14.7, argon is 37.9, krypton 73. At the end, xenon, its solubility is too much high, which is 110.9. So when we move from top to bottom in the group, the solubility in water also increases. At the end, here we have heat of vaporization, that is in kilojoule per mole, that what amount of heat is released when or required to get them into the vapors. Helium is 0.08, neon 1.77, and at the end, then 6.5, 9.7, 13.7, and 18. It's mean when we move from top to bottom in the group, there is an increase in heat of vaporization. All the properties are going to be increased just except the ionization energy. It is going to be decreased when we move from top to bottom in the group. So this was a simple topic about the noble gases and their properties as well as their introduction. I hope you guys understand, and if you have any queries you may ask me about that in the comment section. The next topic that we will discuss, it is a compound of xenon that is denoted as Xe. It is the noble gas. For that time you guys keep learning and have a good day.